Hey everybody, welcome back to the Engineering Entrepreneur Podcast. It's your host Scott Tarcy, fresh off from voice surgery. Should not even be talking as much as just last Friday, like 5 days ago. But we'll let Dan, our guest, do most of the talking. Just the quality intro stuff. I run CADdesignhelp.com. If you've been listening for any amount of time, you can do that. Go to my website, CADdesignhelp.com, and then sign up on the email list, and we'll send you a free PDF, and then you'll be kept updated on everything. Try to leave a review on iTunes or whatever podcast app you use. For any feedback, you can email me info@CADdesignhelp.com. Our guest this week is Dan Simpkins, and he's the CEO and one of the founding partners of Dwellwell Analytics Incorporated. And the company's developed an Internet of Things SaaS product that helps protect residential real estate assets. That's about all I can talk for right now. So Dan, I'm gonna let you go ahead, fill us in on your background. Let's do your background first so people know your history, and then we'll talk more about your company.
Yeah, great, Scott. And I hope that your healing happens quickly and you can get back to doing these without straining. But I'd be glad to take the lead, and I appreciate you having me on the podcast. I am, as you said, I'm the founder of Dwellwell Analytics. My background is in engineering. I'm an electrical engineer. As a kid, I always had nerdy tendencies and was always interested in science and math and technology. Turns out my father had a double E degree, although he never practiced. And frankly, our basement was filled with old electronics, and I was always intrigued by building things. And so I ultimately went on. I got an undergraduate degree from Cornell in electrical engineering. I went on to get a graduate degree in biomedical engineering, and have been practicing as an engineer ever since. I wound up leaving college. I wound up working for several really interesting companies. I started actually developing radars early on, and then shortly thereafter I went into the telecommunications industry, and I actually became one of the world's experts in what's called wide area communications, basically communicating over long distances. After working for a couple of companies as an engineer, doing product development, I decided to start my own company. I actually had an opportunity to start a company, and so my first entrepreneurial venture was a company called Salix that was a pioneer in actually.
How do you spell that?
That's SALIX, Salix Technologies. And what Salix was a pioneer, Scott, in voice over IP, which we're actually using right now. And so we at Salix created not only some of the first high-speed optical communication systems that built the backbone of the internet, but we ultimately went on to create foundational technology in internet communications, and that ultimately led to that company being sold. That was actually an important milestone because at the time we were building our voice over IP platform for telephone companies. I met Chuck Gritton, who was at the time the chief technology officer of a large telecom equipment company called Tellabs. And he was looking for technologies to help grow Tellabs' portfolio. And at the same time, I was looking for a particular kind of technology that I needed in order to make voice over IP work. We got together. We actually realized that it was a natural partnership, and Chuck recommended to his leadership team that Tellabs buy my company, Salix. And that's what happened. He likes to joke that he bought a boss because I became his boss and ultimately ran all of the internet-related divisions within Tellabs. Really, that was a great gig. We met. We've actually been working together ever since, almost 25 years. And so that was really sort of the start, both the start of my career and the start of my entrepreneurial career.
What was the company that bought your company?
the company was called Tellabs. So Tellabs was one of the leading manufacturers of a product called an optical cross connect. In particular, Chuck's expertise, which is very relevant to what we're doing today at Dwellwell, is in audio communications and audio signal processing. And Chuck had been one of the real leaders in an important technology that really is critical to every long distance phone call or communications that we make. Chuck early in his career developed echo cancellation. If you send the signal long distance, when it gets to the other end, it bounces back and it creates echo. And I know, today with Zoom or Teams or Google Meet, often you can get on a connection that doesn't have a good echo canceller, and you'll hear your voice, coming back at you. So that was really one of Chuck's early claims to fame, and ultimately went on to become the chief technology officer at Tellabs before the communications and .com bubbles collapsed in the early 2000s, when both of us left and went on to work together subsequently at other startups.
Okay, so I was curious how that company got ended by the .com bust.
It ultimately, Tellabs didn't end at the .com bust because it wasn't a true .com, but over time, as the telecommunications bubble collapsed, a lot of telecommunications companies struggled because they had overexpanded, and then they got kind of ahead of their skis, and so Tellabs began to struggle as a company, and Chuck and I both left. Interestingly, Chuck went off to start his own startup in the mobile area, and I went off to start a startup called Hillcrest. Because of the challenges in telecommunications and what was going on in the market, it was clear that Chuck was going to struggle to get his startup off the ground. And so, as soon as was practical, I invited him to join me at Hillcrest, my second company, to become my head of engineering, my CTO. And we've worked together ever since.
I just want to touch base on what Hillcrest was before we get into your current company, just so we get the whole history.
Yeah, so as I said, at Salix, we created products to make voice communications over the internet possible. But I eventually knew that video would come to the internet as well. And so when that happened, we predicted that the amount of content on the internet would grow exponentially. And that would require a new technology which would allow consumers to merge online, cable, and personal media in one place. So that's exactly what we do today with products like the Roku and Apple TV, as well as smart TV products like LG or Samsung. And so we were fortunate at Hillcrest to be pioneers creating the first TV OS. And that ultimately led to the formation of what we now call smart TV.
So you created the first streaming TV?
We did. We created the first streaming platform for television. It was it was actually a really heady time. No one had really done this effectively before. At the time we did this was in early 2000. So we started the company in 2001. We had our first platform in 2003. And the whole idea was to enable television to display or really bring together more than just broadcast television, and to create a mechanism to navigate all of that content, your streaming content, your broadcast content, and even personal media, your music content, your photos, and ultimately your videos. And thinking about that, we actually did something quite unique, and it's very relevant to what we ultimately did with Dwellwell, which we'll talk about. So we knew that if all of this content was going to come to television, the traditional remote control, the 50-button remote control, was not going to be an effective tool. The user experience to navigate thousands of channels or tens of thousands of channels was going to break down. And so we conceived of the idea of making an OS, a graphical OS, that would use a mouse to control the experience. And, just like the mouse really transformed the PC, we wanted to have the mouse transform television. Turns out that for a lot of reasons, this was a much harder thing to do than in the PC world, because television was controlled not by a single company like a Microsoft, or maybe a couple like Microsoft and Apple, but by dozens of companies that made televisions, companies like Sony and Samsung and LG and many others. And so creating the idea of an OS that all of them would use wound up being very difficult. Today, if for your listeners, if you have an LG television, though, LG has a product called the Magic Remote, which is a 3D mouse that controls the television, their smart TV experience, which is visual in nature. All of that technology originated with Hillcrest. And so we created all of the foundational underpinnings that allowed smart TV to emerge. Things like streaming apps from the cloud, or
so you beat Apple TV to the game then?
Yes,
I always thought they were the first ones.
Nope, no, we preceded Apple TV, and actually, I had, yeah.
Well, on both of these companies, it seems like there's a lot of intellectual property, a lot of patents. Like, did you guys patent this stuff when that Hillcrest, and then as a result, are you like leasing it like to these other companies now?
Yeah. So the answer is yes. It turns out Chuck and I ultimately became some of the world's experts on creating patents, on both prosecuting or writing patents and deploying them. The company in its peak had over 400 patents that covered almost all aspects of interactive television. And so that was significant. Ultimately, we even had to litigate. There was a large company, which most of people know, Nintendo and the Nintendo Wii gaming platform infringed our patents, and so we wound up having to file a patent suit against Nintendo. And ultimately, after that suit was resolved, we went on to license our patent portfolio to almost all of the major consumer electronics companies. And that was a really important part of our business, not only creating
So was the Nintendo thing ultimately decided in your favor?
I will say that it was settled to our satisfaction.
Okay, so it never went to court, or if it did, it was settled before the judge or the jury decided on it.
It did go to court. We did actually take it through trial, but ultimately it was resolved out of court.
Interesting. So you had a jury trial, or just a judge deciding on it?
It was a judicial trial. We tried that suit in the International Trade Commission and the ITC. So those are judicial trials.
Is it like okay, I never heard of it. Is it like a group of judges then?
No, it's a single judge.
And you said international, so it's based out of the U.S. or what country?
It's based in the U.S. So the ITC basically manages, jurisdictionally, it handles imports and exports. So any case that involves importing a technology into the U.S., if that technology is infringing a U.S. company, then you can actually sue in the international trade, in the ITC, and litigate it that way in front of a judge. So there are risks. So it turns out when you sue the ITC, you can't. There are no damages. You don't. The judge does not award any damages. So there's no financial component, and so that's a little bit of a downside of suing in a district court. But what the judge can do is prevent the product from being imported. So obviously that creates economic pressure on the company that is involved, and therefore they generally the result will generally be a license relationship where the company will license that IP. So to jump ahead, because we could take a lot of time in talking about patents,
yeah.
obviously. But this is important because what Hillcrest had done is not only produce really groundbreaking technologies in streaming services, in the user experience for television, but we had developed this very unique remote control that involved sensors and essentially an air mouse, a 3D mouse that you could basically hold in your hand and just point and click on the screen. And like I said, today LG ships their remote control that has that basically is still designed by Hillcrest. And Hillcrest was purchased in 2016 by and is now today a division of a NASDAQ company called CEVA. So today, Hillcrest handles a lot of sensor technology for the consumer electronics industry as a division of CEVA, and so it lives on, and they're very successful today. Hundreds of millions of products out there in the wild are use Hillcrest technology in one sort or another. Everything from smart TVs to robots, and lots of products in between. So that was a great entrepreneurial experience for me. And so jumping, so you might ask the question is, how did I get from telecommunications, right, to doing voice over IP to content, video over IP in terms of television, into a company that's basically building a diagnostic platform for homes. And so that's sort of a nice transition. If that works for you, we'll transition into Dwellwell.
Yeah, good.
Great. So we were making technologies at Hillcrest that basically blended sensors, in Hillcrest case, motion sensors, with machine learning, because every user is different. And so in order to make the device work consistently across millions of users, we had to make that algorithm adaptive. And we did it using early forms of AI. And so we had this real expertise. Well, while I was running Hillcrest, a vacation home that I own had a couple of frozen pipes thaw, and the house flooded and was really severely damaged. And after putting the house back together again, I was walking the floor of the consumer electronics industry, or the Consumer Electronics show, which is basically the show of the CEA. And I had this observation that a lot of innovation was happening at the time. This was in 2016 in home control. A lot was happening in home automation, but really no one was thinking about the health of the home. And so as I was actually flying home, I sort of realized, wait a minute, there are hundreds of millions of cars on the road, and they all have a check engine light. They all have a sensor network that figures out what's going wrong and gives you a signal of what's happening before you get stuck on the side of the road. But yet our hundreds of millions of homes don't have this technology. And so I came back to the team and I said, I have an idea. Why don't we make the first check engine light for residential properties? And turns out just months after I conceived of that idea, we sold Hillcrest. And, the acquirer wasn't interested in this market or this technology. And so as part of that transaction, I took ownership of this idea. And so we went to work for the acquirer. We integrated Hillcrest successfully. And then, I was sitting and talking to Chuck, my CTO at the time, and I said, Chuck, we have this really great idea, and it looks like there's a real problem out there. And, if you think about entrepreneurship, a lot of entrepreneurship is trying to take technology and solve a meaningful problem that a lot of people have. That's ultimately how you make money. And so we realized that, residential real estate is the largest asset class in the world, $350 trillion asset class. And it is, it is really the maintenance of that asset class is largely manual. We don't really we don't fix anything until it breaks. So it's very reactive. And so we said, well, what if we could take our sensor knowledge and our machine learning and AI knowledge and really create this idea of a check engine light for residential properties? And so that's what we did. So we left.
Yeah, I mean, it makes complete sense. And like the example of your frozen pipes, it's at a high level, it's very easily solvable because you just need a temperature sensor like in there that says, hey, if this is below 32, like we got to set up an alarm and let the homeowner know that, this pipe is freezing or will be frozen soon. And it's once it freezes, it'll crack and then it'll flood when it thaws out again. So,
right, that is, you just hit the nail on the head. And actually, I'll take it one step further because I'll tell you a little bit about the situation in my house. What had happened was that somewhere along the line, when the house was being built, a plumber needed to do some work in a bathroom, or actually a couple of bathrooms. The insulation had already been put in the walls, so it was in the way. So when the plumber opened the wall up to fix whatever this plumbing was, the plumber took the insulation out of the wall, and then they patched the wall back up, and the insulation was never put back in, at least in these small sections. So interestingly, the temperature sensor by itself, just, let's say the thermostat monitoring the temperature, wasn't enough because the room, where the thermostat was not the room that had the poor insulation. And so what we discovered was this idea called ambient inference, that if we could distribute temperature sensors around the home and we could look at them holistically, we would actually be able to determine, wait a minute, the efficiency of the furnace is such that most of the house is heating at a rate of, I'll just make up a number, 5 degrees per hour. But the bathroom, for some reason, is heating at a much slower rate, 2 degrees per hour. And I wonder why that is. And so the whole idea of this check engine light, this sensing and AI system, is to start to look for anomalies that give you early warning that there's a problem that needs to be addressed before the pipe froze, which is exactly what happened. The pipes froze. And when they thawed, the house was flooded and we incurred tens of thousands of dollars of damage because no one was there. And the pipes were flowing for days before anybody encountered them. So that's the whole idea, is to use this ambient data is basically to create an umbrella of sensors, different sensors, not just temperature, but temperature and humidity and electrical sensors and pressure sensors and acoustic sensors and vibration sensors. So we created this universal sensor that is now taking in data in many different ways and then using that data effectively to create those early warning signs.
Yeah, and I think that some other companies may be doing this already because you have a thermostat in every room, and I somehow it's tied into the central AC unit where it's like, okay, we're going to send hot air to this room because it's colder, and I don't know how all that works, but I believe this exists or it's at its beginning phases right now.
Yeah, so this is a great point because the way so that product exists. So there are thermostats today, thermostats specifically, that collect temperature data from multiple locations, generally 2 or 3 locations, not the whole home, but a few locations, and they average that together, but they can also signal, hey, this zone, if you have the right equipment, this area of the house needs more heat than the other. The challenge that exists is, so that's a singular solution. You're not necessarily figuring out what's wrong, and one of the things that we've learned is that roughly 40% of the failures in, for example, HVAC equipment comes from how the system has been installed, not how it's actually the core unit is working. And so part of what ambient inference is doing is helping you understand how is the building behaving holistically, as opposed to how is the system sensing and operating, and then making that comparison. But secondarily, so that product does exist, we'll call it a multi-sensor thermostat. So but there are many of these diagnostic products that exist today in silos. So today you can buy a water leak detector, right? Or you can actually buy an electrical monitor that monitors whether there are shorts in the wall. And you can monitor things like air quality. So you can get an air quality sensor. But in order to monitor all aspects of the home, you now have to cobble together these multiple solutions. So our customers, who are often commercial owners, so people who own real estate at scale, residential real estate, they need to, they actually need to monitor these multiple properties across all of these dimensions. And that creates a real challenge. That creates an economic challenge, because now they not only do they have to bring multiple siloed solutions to their properties and install them, but now they have to manage them. And instead of one app, they might have multiple apps. And so and on top of that, if you're monitoring water and somebody else is monitoring electrical, but what are cases where those two are working in concert? You know, maybe you have an electric hot water heater and you want to see, like, how is the electric usage, right now, changing based on water usage. So a lot of what we've done in terms of our innovation isn't necessarily to create a replacement of these individual systems, but to create a holistic platform that enables us to deliver maintenance as a service. So that's the way we like to describe our product, is we're giving you the ability to convert reactive maintenance to proactive maintenance, and ultimately to predictive.
Yeah, that makes a lot of sense.
Yeah. So really, really important to think about it that way. And what we have found is there are very few companies that have the breadth of sensor and analytics capability that we have. And so many of these companies take a thermostat, it knows, what you've set, that, okay, the temperature is set at 70 degrees, and you should, if it's below that, turn the heat on, and above that, turn it off. And they may even learn a little bit. They may learn how fast the house heats up, and so they can anticipate and start a little bit early so they get to the set point at the right time. But these products are not employing AI comprehensively to understand what's going wrong, and helping either owners or landlords get ahead of their maintenance. And that's a lot of what we're doing, is really focusing exclusively on making sure that problems get caught early and don't become costly and catastrophic.
So how do you integrate AI in?
Yeah, so we do AI at the edge. We do AI at the edge, where we are, the way it works is we take our sensor data, and then what we've built are a series of classifiers that are that then learn, they learn what is the sort of standard behaviors, and we actually do a combination. We have a layered analytic system, so I'll explain that in a second, but we then learn the environment, we look for changes in that environment, and then based on our historical expertise, we then we are able to predict or signal when changes exist or anomalies occur that need to be addressed. And so the way our analytics system works is fairly sophisticated. it starts at the physics layer where we just simply take sensor readings and then we manage those either directly or through, through physical algorithms. So we combine sensor data algebraically in order to produce outcomes. We also then do statistics. We have a statistics engine where we could look at ranges. We could look at variations of data and determine when has a particular parameter either gone out of range or into range, or or it's in range or it has gone out of range. And then the third layer is the true AI, and that's your question, where we've built neural networks that are designed to analyze these signals and determine when something is wrong directly. So a perfect example of that is that we can tell, we have used AI to learn what a toilet sounds like when it flushes. And we've learned what a toilet sounds like when it fills. And interestingly, one of the single largest losses of water in residential properties are running toilets, which have faulty flapper valves. And you can lose 1 to 300 gallons of water a day just in your toilet. And so if you got an apartment building and 10% of your toilets are running, that's a lot of water a day. That could add up to hundreds of dollars of water cost a day just from running toilets. So the way our AI works is we've trained the AI to learn what a toilet sounds like. And then when the toilet, we have a state machine, we sort of have a model of the normal operation of a toilet. And when the toilet is misbehaving, we can then report very specifically the toilet has flushed and didn't fill, or it's running, it filled but didn't flush. And then we report those alerts to our customers through either a web experience or a mobile experience. Either, and that's how it works.
On that topic, not related to your company, but if this toilet flapper is such an issue, which sounds like it is, how has nobody improved this product that's been the same for 80 years? Like, let's address the root cause here and somebody make a better seal or valve or some kind of design. It has to be a better solution than if it's this bad.
Yeah, it's a great, well, think about it. Necessity is the mother of invention, right? That's where entrepreneurship comes in. And so maybe that's your next startup is improving toilets. But joking aside, there are billions of toilets out there, right? And the challenge, it happens that flapper valves work extremely well because it is a dirt cheap solution to a problem. But toilets are improving. There are new mechanisms that are coming into play. So there's new technologies that exist today that do a little bit better job. But ultimately, all toilets have a valve that basically, when you flush the toilet, it allows the water to go down the drain and flush, and then that valve has to close. And so, regardless, it's the key is to be able to do that at scale cheaply, and because it has to be very cheap, it ultimately wears out. And so, but the problem is that it's out of sight, out of mind. I mean, most people don't know that their toilets are running. They don't know how to recognize it. And if you're an apartment building owner and you have 500 toilets in your building, and they're behind the door, until your resident tells you that the toilet is running, you'll never know. You may be getting a big water bill, but on average, if on average, a certain number of toilets are running, you may just think that your high water bill is what to expect because you've been running the building for years, maybe decades. And so it's an interesting problem. It's a great question, but it is one of the reasons why one of the very first AI analyses that we built was to detect a running toilet.
So have you guys already started implementing these, or is this are you still at the beginning stages to where you haven't actually put one of these into an apartment complex yet?
No, we are in production. We started the company a little over 5 years ago, about 5.5 years ago. 2 years ago, we did an alpha trial, or 3 years ago, we did an alpha trial. 2 years ago, in 2022, we did our beta trials. And then in this year, the beginning of 2023, we went into production. So today we have about 500 homes that are being monitored by Dwellwell, a combination of apartments and single family homes. And it's still early. It's an early process, but we just a few months ago hired our first sales person to really take ownership of the sales process so that we could start to scale our product and get it out there.
Very cool. Well, let's get towards wrapping up. So what is your number one tip from all your life experiences here for the audience?
So my number one tip, you know, I would start, so I usually like to tell entrepreneurs, don't let conventional wisdom get you down. Don't, you know, it's very common to have people say, that's a crazy idea. And you know, and really discourage entrepreneurs. And I early in my career, I created this concept called the 10 laws of the entrepreneur. And one of those laws says you have to go over the line to see the line. You have to imagine yourself in the world of science fiction, and then kind of turn yourself around and see where the line between reality and science fiction is, and then really figure out how to move that line forward to improve the world in some way or another. And so I always am cautioning entrepreneurs to not, not be discouraged by people thinking your idea is crazy. And to that end, and I'd say this is a corollary to my number one tip, is that really early on, an entrepreneur should really seek to use mentors in the best way you can to learn. Every entrepreneur needs to know how to find mentors, know how to leverage them, and really recognize that you don't have all the answers. That what you're trying to do is really hard. It can be very discouraging, and to really bring smart people around you and to listen. And so those two often for me are two tips that go together.
That's great advice. Lastly, what's the best way for people to get in contact with you?
Great. Well, there are a number of ways. I'm on LinkedIn. You could look me up, Dan Simpkins at Dwellwell. Our website is dwellwell.ai, and there's a way to contact us there. And so those are really the two best ways for me, LinkedIn and through our website.
All right, great. Dan, well, that wraps it up. Thanks for your time, and we'll catch everyone next time on the podcast.
Great. Well, it's a pleasure, Scott. I really appreciate you giving me the time today. And again, hope your voice gets better soon.